Because when we learned how to take square roots, and that was information that we will need today. So don't you love how that works? Today is the 15th. Please put a date on your notes. It is really important that you have dates on there. Okay, so yesterday we talked about square roots. And so I reminded you of our perfect square numbers. And we went through the whole list all the way up to 12 squared. And what we have are these lovely perfect square numbers. I even talked about what that means to be a perfect square. And I said that if we know our perfect squares, then what I can do is we can take the square root of a perfect square. And if I can take the square root of a perfect square, the square root gives us back the actual root of that perfect square number. So here's our perfect square, and whatever the base happens to be is the root. That's what we call the root, all right? And so we're doing that again today, looking for all of those perfect squares. And I have a do now that I wanted you to do. And the way I want you to think about this, instead of trying to solve, is to just think to yourself, well, what number squared gives me 25? So ladies and gentlemen, what number squared gives you 25? 5, sure, 5 squared does give you 25. So there's an answer, that's good. So 5 squared gives you 25. Is that the only one?
Yeah.
Is it?
Negative squared.
Negative 5. Negative 5 squared also gives you positive 25 because what are we squaring? We're squaring everything, writing it out 2 times, and negative times negative is going to give us that positive 25. So there's actually 2 numbers, positive 5 and negative 5, plus or minus 5. And that's something we want to remember whenever we have an x squared equation, which is called a quadratic equation anytime we have an x squared. There's always going to be 2 answers. That's what that power tells you, that there's going to be 2 solutions for x, okay? We must remember the plus or minus. So plus or minus is the word of the day, and that's what we want to remember. Okay, that's 2 different answers, a positive 5 or a negative 5 for our solutions for x. So today we're solving quadratic equations by taking square roots, also known as the square root method. So that's what I'll call it. This is the square root method, which means we're going to eventually take a square root, and that's why we learned how to simplify square roots yesterday. We talked about looking for perfect square numbers, and then we also did some rationalizing, which you will have to remember today as well. So example 1, solve the equation, and then use your calculator to check. So if you have a calculator, I do want you to have that out. We will check one of them together, and I'll show you a new thing. We'll check the last one. But again, I really want you to remember, in math, the beautiful thing is that you can check your answers. You can know if you get 100%. It's not like the English paper you spent, 30 hours writing and then got a C on at a whim of your teacher. I'm so mad about that. Sorry, that was a personal experience. Okay, I hate English. Not really. I actually really like it, but I did hate the grading. I got a C? Explain. Why? What was wrong? Thesis, transitional statements, details, examples, citations. It's all there. How come I got a C? What? Sorry. Okay. I digress. Let's do some math because math is better. Okay. All right. The square root method, when we're using the square root method, our goal is to isolate whatever is being squared. isolate whatever is being squared. So in this first equation here, what's being squared? The x. So that's what we want to isolate. We're going to isolate whatever is being squared. And so our job is to get that all by itself. So what are we going to get rid of first? We want to do any adding or subtracting if we can. Yeah, so we're going to subtract 7 first so that we can do, we always want to do any adding or subtracting. I don't know if I've ever mentioned this before, but you know how, or what's order of operations? So PEMDAS, when we solve things, we do PEMDAS in reverse, which is SADMEP. Yeah, have you ever heard of SADMEP? No, yeah, I'm sorry I've never mentioned it. It's kind of one of those hidden things we talk about. But when we're solving, we want to do any adding or subtracting, and then we want to do any multiplying or dividing. And this is exactly what we're going to be doing on this problem. So the first thing we're going to do is subtract 7. That gives me 4x squared equals, what's 23 minus 7? 16. All right. Again, our goal is still to isolate that x squared. So what do we want to get rid of now? The 4. How are we going to get rid of the 4? Divide. Yeah, this is 4 times the x squared. So we're going to do some multiplying and dividing. We're going to divide by 4 on both sides. All right, so that gives me x squared all by itself on the left. What's 16 divided by 4? 4. Okay. And then now you'll notice exponent. I want to get rid of this exponent. I want to cancel it out. What undoes a square? The square root. Cancels it out. So we're going to take a square root. That's why it's called the square root method. We're going to take a square root of both sides. When we take a square root, you must remember a plus or minus. So write it down. Always, always. You always have to have a plus or minus when we use the square root method. The square root and the square are inverse operations. They cancel each other out. It's kind of nice. The square root of x squared is just x. And then we have plus or minus the square root of 4. Well, this is what we did yesterday. What is the square root of 4? 2. So we have plus or minus 2 for our answers. Those are 2 answers if you want to be really extra careful here. X equals 2 or x equals negative 2. 2 answers for x. Okay. But usually we just stick with the plus or minus 2. So that's the Twitter version of the answer. Fewer characters. I don't have a Twitter account. I'm just saying, I know nothing about it. Okay. Do you guys even use Twitter anymore? Or Snapchat? Or something else? All of the above? Okay. All right. Or Instagram, probably, huh? Okay. All right, here we go. Next one. What are we trying to isolate? The x squared. Yeah, this thing. We have a lot of stuff that we want to get rid of. I want that x squared all by itself. What are you going to get rid of first? The 3. Yeah, sure. This is a positive 3, so how am I going to move it? Subtract 3. Good. When I subtract that 3, that goes away, so what's left on the left-hand side? Negative x squared over 2. Good. Equals, what's a negative 9 and a negative 3? Negative 12. Good. All right. This is a tricky one. What do you want to do now? Times by net. Oh, good. More than one person said it. Good. That means I can do that. You could do this in lots of different steps, but I want just this x squared, which means I need to get rid of this divide by 2 and the negative. We're going to multiply both sides by negative 2. Divide by 2 and times by 2 cancel each other out. And what happens when we have a negative times a negative? It turns to positive. Okay, and that's what we want. And so we're left with a positive x squared equals, what's negative 12 times negative 2? Positive 24. Very good. Negative times negative is going to give us that positive result. All right, and then how do I get x? How do I get rid of this power of 2? Square root. We're going to take a square root of both sides. Don't forget, say it out loud. Don't forget the plus or minus. Thank you, thank you, thank you. All right, so the square root and the square cancel out, leaving me with a plain old x equals plus or minus. I'm going to do a little shorthand here. We're trying to simplify the square root of 24. What are my factors of 24 to use? 4 times 6. 4 times 6. Those aren't the only factors, but those are good ones because we have a perfect square here. What is the square root of 4? 2. So a 2 escapes. Can I take the square root of 6? It stays. So we simplify that radical as 2 radical 6. Okay? Plus or minus 2 radical 6 is a great solution. Do you guys have any questions so far? All right. These ones get a little more complicated. Actually, a lot more complicated. We will spend a while on this method. 3 times the quantity 2x minus 1 squared equals 54. Those parentheses are really important. Again, when we're using the square root method, we want to isolate whatever is being squared. So what are we trying to isolate here? Yeah, that whole bubble, that whole thing there that's in parentheses, we want to isolate it. Whatever is being squared. So what do we need to get rid of first? The 3. How do we get rid of the 3? Divide. That's right. So this is 3 times this whole bubble. Can I distribute in the 3? That's all under the simplify heading, and order of operations, as PIMDAS, that says you have to do exponents before you can do any multiplying in. So we actually are not allowed to distribute in a 3, but we can divide it off. So let's just get rid of it by dividing both sides by 3. Then I'm left with 2x minus 1 quantity squared equals 54 divided by 3. 1/8. Good. So again, now I'm to the power thing. How do I get rid of this power of 2? Square root, yeah. So what I'm trying to do is I'm trying to get inside at the x. I'm trying to whittle things down. Right now, this 2 is on the outside of my function. I've got to get rid of it. So I'm going to take the square root of both sides. Don't forget the plus or minus. So my square root and my square cancel out. And what's left over here? 2x minus 1 equals plus or minus, and I need to simplify radical 18. What are my factors of 18? 9 times 2. Very good. Those are good factors. 6 and 3 also works. Why do we use 9 and 2? Perfect square. 9 is a perfect square. What is the square root of 9? 3. And we can't do a 2, so it stays. All right, so plus or minus 3 radical 2. Now, I still have to isolate x. So how do I get x by itself? Add the 1. Good. So we're going to add 1 to both sides. So I have 2x equals. Now here, it's kind of a trick question. Can I add the 1 and the 3 together to get 4? That's a no. So the 3 has this radical attached to it. That makes it a totally radical number. And the 1 is a regular Joe. They don't mix. So that 1 just sort of gets inserted there. 1 plus or minus 3 radical 2. And you just get to leave it like that, which is really, really quite nice. And then how do you get x by itself? Divide by 2. And we want to make sure that we divide everything by 2. We're going to divide the 1 by 2. We're going to divide this term by 2. Every single thing gets divided by 2, okay? Every single term. So those cancel out, leaving x equals 1/2 plus or minus 3 radical 2 over 2. And that's a great answer. It's a complicated answer. And I want to write it out so you can see how we get the two answers for x. We would say 1/2, and we're just going to take the positive 1/2 plus 3 radical 2 over 2. What's the second answer then? 1/2 minus 3 radical 2 over 2. So these are the individual solutions. You can plug those answers into your calculator. We'll do the next one. You can plug those in. You'll get two very, very different decimal approximations. Okay. So let's try the last one here. We have 1/5 times the quantity x minus 4 squared plus 2 equals 6. What do you want to do first? We're trying to isolate. We're trying to isolate whatever is being squared, yeah? So what do we want to get rid of first? The 2. Remember, we want to do any adding or subtracting. So we have this plus 2. We can subtract it to the other side. 1/5 times the quantity x minus 4 squared equals 6 minus 2 is 4. Now I can deal with this fraction. What can we do to get rid of the fraction? Times by 5, yeah. You could divide by 1/5, but I really, really, really hate dividing by a fraction. So instead, we can multiply by the reciprocal. What is the reciprocal of 1/5? 5 over 1, or just 5. So we're going to multiply both sides by the reciprocal. Times by 5, or 5 times 1/5. Turns out to be 5 over 5. And 5 over 5 is just 1. So it multiplies itself away, which is nice. We're left with x minus 4 quantity squared equals 4 times 5, which is 20. Now what should we do? How do you get rid of the power? Square root, square root both sides. Don't forget what? Plus or minus, very good. The square root and the power, the square root and the square cancel out, leaving us with just x minus 4. Do I need those parentheses anymore? Not necessary anymore, because we got rid of our power, so they don't need to be there. We have plus or minus, and we got to simplify the square root of 20. What are my factors for 20? 5 and 4. 4 times 5, good choice. What is the square root of 4? 2. And then the 5 stays under the radical because it's not a perfect square. And then how do you get x by itself? Add the 4. So we're going to add the 4. And again, can I add the 4 and 2 together to get 6? No, they're not like terms. This is a totally radical number. This is a regular Joe. They just sort of sit next to each other. 4 plus or minus 2 radical 5. This is a great answer. But what I want to show you right now is how to check these on your calculator. So make sure you have your calculator out. And in order to check these answers in your calculator, you need to separate them first. So what's one answer? 4 plus 2 radical 5. What's the second solution? 4 minus 2 radical 5. So these are your two answers. And what you're going to do with your calculator, it works with a scientific one as well, any of them. So we're going to go ahead and get a decimal approximation. I'm going to do it two different ways. I'm going to show you decimal approximation way. So we're going to type in 4 plus 2 radical 5. So you should be able to find your radical button on your calculator. It's a second function. On my TI, it's right over here. You have to do second and then the radical. So 4 plus 2 radical 5, and it gives me a decimal approximation of 8.4721, and it goes on and on and on. That decimal is what we call an irrational number. It's irrational. It cannot be written as a fraction. It goes on forever. Okay. Now, how do we check equations? What do we do when we get an answer? What do you do with your value for x? Don't you plug it back in? So what we're going to do is we're going to take that value and we're going to plug it in place of x. 8.4721. I'm going to plug in that approximation into my original, just the left-hand side here. So I'm going to type in 1/5. And then my parentheses, what am I going to put in place of x? 8.4721. And then I have -4, parenthesis, squared. And then I have a plus 2. So I'm just plugging it right in there. You can't see what. There you go. Okay. What number am I expecting to get? Yeah, it should equal 6. That's what it tells me it should equal. Do you think it's going to be exactly 6?
No, probably like 5 points.
Yeah. So it's not going to be exact because I rounded it off. So I'm going to get here, and you can see we get 5.99999. I rounded it to 4 decimal places, and we got really close with 4 decimal places close, okay? So really close. But I want to show you another way. So I'm going to use the second answer, and I'm going to go ahead and get my approximation. 4 minus 2 radical 5. Again, we get a negative number here, -0.4721, ... Again, it goes on forever and ever. But I want to show you, all of your calculators have an answer button, A and S. So when you look on your calculator, this one, it's down here. It's a second function, so you do second A and S, and that button says it's going to take the previous answer, whatever your previous answer was, and it'll plug it in. So what I'm going to do is go back up here to my original. I'm going to type in my 1/5, parentheses. Now, instead of rounding it off, I want to use this whole answer I calculated out right here. So I'm going to do second answer. All right, second answer. And that's going to use this exact answer that I typed in, -4 squared plus 2. That's kind of handy. And then, do you think it's going to be close to 6 or exactly 6 this time? Exactly 6, because I'm using essentially this exact answer. All right, and so there it is. It totally equals 6 when you check out. Okay, so all of you should be able to find that answer button, and that could be really, really helpful. All right, do you have any questions for me? All right, then you can get started on class practice 47. And just so you know, tomorrow we'll be finishing class practice 47. So you won't probably finish it today. You'll have maybe 5 questions left to do, and we'll finish those tomorrow during class.